Lesson 8.5, Quadratic Equations, Difference of Squares. Today we will learn how to factor a specific kind of quadratic equation that we will call a difference of squares. And I think your biggest challenge is not going to be factoring it, because that's rather simple. It's going to be recognizing it. So we're going to simply learn what it looks like and keep our eyes out looking for differences of squares. In Lesson 7-8, we learned how to recognize the pattern of special products. One of those was the product of a sum and difference. If you recall, we learned that when we multiply a sum and a difference, such as a plus b times a minus b, the product is a difference of squares, the first term squared minus the second term squared. Well, now that we're factoring, we will simply follow the pattern working backwards. We will learn to recognize the difference of squares, a squared minus b squared, and we will learn that it equals a plus b times a minus b. Okay, let's practice this skill. Number 1. X squared minus 25. This is a difference of squared because the first term is a perfect square, x squared, and the second term is a perfect square, 5 squared. So in order to factor a difference of squared, you take the square root of the first term, that would be x, plus the square root of the second term, which is 5, times the square root of the first term, x, minus the square root of the second term, 5. And that's it. That's the pattern you will follow. Okay. Number 2, t squared minus 64. Again, we will simply follow a pattern to factor a difference of squares. So this would be t plus 8 times t minus 8. Number 3, 16h squared minus 9a squared. Okay, this is also a difference of squares. And when we factor it, we have 4h plus 3a times 4h minus 3a. Number 4, 27g cubed minus 3g. Notice here that we have a GCF. If we have a GCF, we will always factor that out first. So the GCF here is 3g. Let's factor that out. We're left with 9g squared minus 1. Notice that 9g squared minus 1, you would be able to recognize that as a difference of squares, so we can factor that. It's following the pattern. It's 3g plus 1 times 3g minus 1. Okay, number 5. Try this one. Negative 4y cubed plus 9y. Okay, notice here we do have a GCF, and we're going to force a difference of squares also by factoring out a negative 1. So let's factor out the GCF, which is negative 1y, and we're left with 2y squared minus 9. No, I'm sorry, that's 4y squared. Let me fix it. 4y squared minus 9. Notice that 4y squared minus 9 is a difference of squares, so bring down the negative 1y, and let's factor out our difference of squares. We have 2y plus 3, 2y minus 3. Okay, number 6, b to the 4th power minus 16. You'll recognize that's a difference of squares, so let's go ahead and follow a pattern to factor that. It would be b squared plus 4 times b squared minus 4. But keep your eyes open and notice that we still have a difference of squares. B squared minus 4 is a difference of squares and can be further factored. So B squared plus 4 comes down. That cannot be further factored, but we can factor B squared minus 4, and that would be B plus 2, B minus 2. Try number 7 on your own. 81 minus x to the 4th power. Factor that. Pause the video and then check your answer. Okay, so the factored form is 9 plus x squared, 3 plus x, 3 minus x. Okay, number 8. Here we have 5 x to the 5th power minus 45 x. All right, look for a GCF and then factor completely. Pause the video and then check your answer. The factored form is 5x times x squared plus 3 times x squared minus 3. Number 9. 7x cubed plus 21x squared minus 7x minus 21. Okay, here we have a polynomial with 4 terms, so immediately I should be thinking that we're going to have to group here, okay? First thing I'm going to do is look for a GCF, and I do have a greatest common factor of 7. Let's factor out the 7 first. So I'm left with x cubed plus 3x squared minus x minus 3. My next step would be to group the 4 terms into two groupings. So let me do that. So I'm going to make some brackets here, and I'm going to just bring down x cubed plus 3x squared, and then plus negative x minus 3. And all I did was just add the parentheses to start the grouping process. Okay, so don't leave the 7 behind. He's part of our factoring. The first 2 terms have an x squared in common, x plus 3. The last 2 terms have a negative 1 in common, x plus 3, and there you see our GCF is going to work. Our grouping is going to work here. So we have 7, don't leave the 7 behind, times x squared minus 1 times x plus 3. You should always be looking out for a difference of squares, and there it is. X squared minus 1 can be further simplified or factored. So we will do that. So let's factor out x squared minus 1. That's x plus 1, x minus 1, and bring the other factors down. So this would be the completely factored form of that expression. Okay, number 12. I'm sorry, I meant to say number 10. Number 10, try this one on your own. W cubed minus 3w squared minus 9w plus 27. Hit pause, work it out, and check your answer. So the factored form is w plus 3 times w minus 3 times w minus 3. You can also write this as follows: w plus 3 times w minus 3 squared. Either one is correct. Okay, number 11. We're going to solve a quadratic equation using difference of squares as a factoring method. So number 11, write this one down. 100 minus 25, equals 25x squared. 100 equals 25x squared. In order to use zero property, product property, we need to make this equal to 0. So let's subtract 25x squared from both sides. So we have 100 minus 25x squared equal to 0. Okay, the first thing I want to see is that I have a GCF of 25, so I'm going to go ahead and factor that out. 4 minus x squared equals 0. Let's continue factoring. This is a difference of squares, so we can factor it out as follows: 2 plus x and 2 minus x equals 0. So here we have three factors: 25 times 2 plus x times 2 minus x equals 0. Zero product property says that one of those three has to be equal to 0. If not, all three have to be equal to 0. So our first one, 25 equals 0, we know that's not a legitimate solution. But we can solve for the other two. 2 plus x equals 0 and 2 minus x equals 0. Let's solve. Subtract 2 on both sides, so x equals negative 2. That is a viable solution. And then here we'll subtract 2 from both sides. Negative x equals negative 2. Divide both sides by negative 1. X equals positive 2. So our solutions are negative 2 and positive 2. Number 12. Please do this one on your own. 4y squared is equal to 9/16. Pause the video, and then when you're done, check your answer. Okay, the roots for this equation are negative 3/8 and positive 3/8. So for independent practice, I would like you to work on 2 factoring problems. You're going to do number 5, and you're also going to do number 21. For solving problems, I want you to work on number 4 as well as number 9. Okay, don't forget to write down any questions you might have, any concerns. We will discuss application of factoring difference of squares. We will practice some more in the classroom. Remember that there may be a quiz in the morning tomorrow during class. It's all possible. So be ready, be prepared. God bless you. Have a great night.